Hello, ladies and gentlemen. Well, tonight is our final night of official chain rule practice. So make sure you take good notes, make sure you're thorough, and that you're clearing up any misconception and doing really good practice. Here we go. Okay, so let's look at this first one. It says, let f be a differentiable function such that f of 0 is 2 and f prime of 0 is negative 3. The function h is given by h of x equals sine ax times f of x for all real numbers where a is a constant. Find the value of h prime of 0 in terms of a. So h prime of 0 here, this is indicating that we're going to have to take the derivative of h and then plug 0 in and evaluate that in terms of a. Just means that our final answer is going to have an a in it. Okay, so let's get started here. All right, so we have to first of all do h prime of x. Well, if I look at h of x, I recognize that I have a product here. I have sine ax, and then I have f of x. So I'm going to use my product rule. First, sine ax times the derivative of the second, which is f prime of x, plus second, just f of x, times the derivative of sine ax. Okay, sine ax, I'm going to have to use the chain rule. First, take the derivative of the angle, which is cosine, keep the angle, times the derivative of the angle, which is just going to be a, our constant. Okay, so now it's h prime of 0. All right, now sine of anything times 0, so a times 0 is just 0, times f prime of 0. So I'm just going to kind of look up at what was given to me, and f prime of 0 is negative 3, so times negative 3. Okay, plus f of 0 is given as 2, times cosine of 0 times a. All right, well, I know that sine of 0, thinking of my sine graph and where the sine graph crosses the y-axis, is 0. So this whole piece is just going to be 0, because 0 times negative 3 is 0. Okay, plus 2 times, all right, my cosine graph crosses the y-axis at 1, so cosine of 1 is, or cosine of 0 is 1, and then times a. So we are left with here as h prime of 0 is equal to 2a. Okay, in this next problem, we're again given a function g, and here it is here. Okay, and you can see we got some stuff going on. G of x is equal to f of x, so there's a composition there, plus x squared times the square root of f of x. And we're asked to write an equation for the line tangent to the graph at x equals 3. So we know whenever we're asked to write the equation of a line, we need two things. We need the point, and we're going to need the slope. Okay, so I'm going to work with the point first. So we already have x equals 3, and we have our function, g of x, and so in order to get my y value, I plug in 3 into my original g function. So that would be f of 3 plus 3 squared, which is 9, times the square root of f of 3. All right, so g of 3 then is f of 3 from up above here is 4, plus 9 times the square root of 4 is 2. Okay, now I go back up to what I was given, and f of 4 I was given as 3, plus 9 times 2 is 18. So I get that my g of 3, which is my y coordinate, is equal to 21. So now I have my point at 3, 21. Okay, so next I want to go ahead and find my slope. So I'm going to go ahead and, first of all, I'm going to rewrite the function g of x, okay, as f of x plus x squared, and I'm going to rewrite, instead of square root of f of x, I'm going to write it as f of x to the 1/2. Alright, so now when I'm ready to find my slope, my derivative here, okay, f of x is a composition of functions, which really means we have a function inside of another function. So this is the classic application of the chain rule. So we take the derivative of the outside, which is f prime, keep the inside, and then times the derivative of the inside. Okay, plus. Now if I look at these next two terms here, I can see that they are multiplying, so I'm going to have to use the product rule after the plus sign here. So we have first, which is our x squared, times the derivative of the second. Okay, here's the other application of the chain rule. So this is the chain rule with a power. You have a function raised to an exponent. So we're going to bring that exponent down. We're going to keep the function, but now raise it to 1 less. So that would be to the negative 1/2 times the derivative of the function. Okay, so that was first times derivative of second plus second, which is just f of x to the 1/2, times the derivative of the first, which is 2x. Just squeezed it in. All right. So we, at this point, have an option of cleaning it up, or we can just go ahead and plug in that g prime of 3. Okay, so I snuck in the function evaluated for 4 and 3 up top here, so I can use those. Okay, so I'm going to go ahead and do f prime of f of 3, well, I'm just going to look right up here and I see f of 3 is 4, times f prime of 3, so f prime of 3 is 5, plus 3 squared, I'm going to plug that in and make that 9, times 1/2, times, okay, so now it's f of 3, which is 4, to the negative 1/2, times f prime of 3 is 5. Okay, plus f of 3 to the 1/2, so that would be 4 to the 1/2, times 2 times 3. So, went off a little bit on my screen there. Okay, so cleaning this up, couple last steps here. Oops. Okay, so f prime of 4, we have as negative 1 times 5, okay, plus, all right, I'm going to go ahead and multiply the 9 here and the 5, and that would give me 45, okay, times, all right, so now I have 1/2 times, what's 4 to the negative 1/2? Well, I know the negative's going to push it down, so it's 1 over, and 4 to the 1/2 is the same as square root of 4, so 1/2 again. All right, plus 4 to the 1/2 we just talked about is the square root of 4, so 2 times 6. Okay, keep working with it. Keep doing that. It should be a 3. Equals, so this is negative 5 plus, okay, so this would be 45 times 1/2 times 1/2 would be 45 over 4 plus 12. Okay, so it looks like we need a common denominator here of 4. So g prime of 3 equals, so I'm going to make these all have a denominator of 4. So 45 over 4 plus something over 4. Okay, so the negative 5 times 4, to make that a denominator of 4 would be negative 20. And 12 times 4 would be 48. So if I go ahead and add those, negative 20 plus 45 is 25. Plus 48 is 73 over 4. Okay, so finally, using this point up here and using this as my slope down here, I'm ready to write the equation of my tangent line is y minus 21 equals 73/4 x minus 3. Okay, that was a long one, and definitely you had to persevere, but when we get to the end, it feels good. All right. Okay, the next couple that we're going to look at are using the chain rule with the product or with the quotient rule. Okay, so chain rule with product or chain rule with quotient rule. And we've already done this, but these ones just kind of end up being a little bit bigger problems, and they're going to involve some factoring, GCF factoring at the end. So I definitely wanted to practice these. Okay, so what we're looking at here is we have the product of two terms that both require the chain rule. So you can see this first term here, okay, 3x squared plus 7 to the 5th will require the chain rule, and then we have 6 minus 5x to the 3rd that will require the chain rule, and those are multiplying. So as we go through and do y prime, okay, you're going to want to write small, we're going to definitely have to use the product rule and within the product rule, the chain rule. Okay, so let's get started here. So we go the first, which is my first quantity there. So that would be 3x squared plus 7, keep it to the fifth. Okay, times the derivative of the second. So I'm taking the derivative of this second piece. So to use the chain rule, that means I'm pulling my 3 down, okay, keeping the inside 6 minus 5x, raising that now to the second, times the derivative of the inside, which is negative 5. Okay, plus second. So now copy your 6 minus 5x to the third, times the derivative of the first. So now again, the chain rule with that first term. Bring the exponent down, keep the inside, 3x squared plus 7, drop your exponent down by 1, times the derivative of the inside, which is 6x. Okay, so stop and take a look at that. Make sure you understand every piece, why it's there. All right, and let's continue on and clean it up. So what I'm going to look at here is either side of my plus sign. Okay, so I'm going to look at this side and I'm going to look at this side. And before I want to do any factoring or any real simplifying, or cleaning up, I should say, what I want to do first is just kind of combine things that can be combined, any constants, just get them out front so I have a full picture of what I'm looking at on either side of the plus sign. So I can multiply the 3 and the negative 5 and make that negative 15. And then I have this first quantity, 3x squared plus 7 to the fifth, and I have 6 minus 5x squared. Okay, now on the other side of the plus sign, my terms that I could multiply would be the 6 and the 5x, or I'm sorry, 5 and 6x, making 30x. And then again, I have 6 minus 5x, this time to the third, and 3x squared plus 7 to the fourth. Okay, so now that I have this, I can see, okay, again, I'm looking at either side of my plus sign, and what I'm looking for are terms that are the same, okay, GCF. I'm looking for things that are the common to both sides of the plus sign. So the first thing I want to look at are my coefficients, what's in front of these parentheses, and I should notice that I can definitely factor a 15 out of both sides, okay? So between the negative 15 and the 30x, I can pull out a 15. Now I start to look at my parentheses and I compare them. I have a 3x squared plus 7 to the fifth on this side, and I have a 3x squared plus 7 to the fourth on this side. So which of those has the smaller exponent? That would be the 3x squared plus 7 to the fourth. So that is pulled out as part of my GCF. Okay, looking at the next quantities, I have 6 minus 5x to the second and 6 minus 5x to the third. Again, I'm going to pull out the smaller exponent, so 6 minus 5x to the second. And then I usually kind of make a bracket. Okay, now remember, this whole piece here is my GCF. So all of this needs to be divided out of each side of the plus sign. And you kind of just take it step by step and kind of think through what you're doing. So first the 15 would divide clearly into the coefficient. So negative 15 divided by 15, you'd be left with negative 1. Okay, now the 3x squared plus 7 to the fourth, that would divide into 3x squared plus 7 to the fifth, leaving us 3x squared plus 7 to the first, or you can just leave it like that. If you notice now, the next terms, the 6 minus 5x squared and the 6 minus 5x squared, they match. So we're done. They cancel each other out completely, and we don't have to put anything inside. Okay, now plus. Now we start over again, and we're dividing this into the other side of the plus sign. So 15 goes into 30x 2x times. 3x squared plus 7 to the fourth, they match this time on both sides, and so we can just drop those. They divide up completely, and the 6 minus 5x squared divides into the 6 minus 5x cubed and leaves a 6 minus 5x. Okay, and that's the end of that parenthesis. So now we just want to clean up what's inside that parenthesis, and then we should be done. So 3x squared plus 7 to the fourth, 6 minus 5x to the second. Okay, so inside this parenthesis, this bracket, I'm going to distribute the negative 1, so negative 3x squared minus 7. And then I'm going to distribute this 2x through, so I'll have plus 12x minus 10x squared. Okay, so my very last step would be to combine like terms here. And I know this is annoying to keep writing this. So 15, 3x squared plus 7 to the fourth 6 minus 5x to the second. And my like terms here would be negative 3x squared and negative 10x squared, making negative 13x squared, plus 12x minus 7. Okay, that was a long problem, but as you work through it, every step has a purpose. So in the end, you can see that we end up with this long answer, but that is as cleaned up as it can get. Good job. Okay, this last problem. We are actually going to approach this problem in two different ways, and we're going to work through both ways. I'd like you to get them both in your notes. It's great practice and really reinforces the quotient rule and the chain rule, and it's going to reinforce a lot of factoring and algebra skills. Okay, so the first one I wrote down is option 1 is quotient inside of chain. And the reason I wrote it like that is because I want you to see it as writing it as the quotient 2x plus 5 over x squared minus 3x all to the 1/2. So here we have a chain rule clearly because we have this big thing to the 1/2, but then inside that, when we get to the derivative of the inside, we will have to be using the quotient rule. Okay, so let's go ahead and get started. So that tells us f prime of x is equal to, all right, so we want to start by moving that 1/2 down. So 1/2, keep the inside, 2x plus 5 over x squared minus 3x. We're going to drop the exponent down by 1, so to the negative 1/2. Now times. Now here's where we do the derivative of the inside, which the inside is a quotient. So quotient inside of chain. All right, so now we go ahead and we do low. So x squared minus 3x. D high, so the derivative of the high is 2. Okay, minus high, so 2x plus 5. Derivative of the low would be 2x minus 3. All over low, which is x squared minus 3x squared. Okay, so now we have a lot of cleaning up to do here. So f prime of x is equal to, all right, so keep that 1/2. Now if you notice here, this fraction is to the negative 1/2. So the negative piece of that tells me to take the flip or the reciprocal of it. So I'm going to go ahead right away and flip this and write it as x squared minus 3x over 2x plus 5, all to the positive 1/2 now. So I took care of the negative exponent. Okay, times now I'm going to work with this piece, the quotient rule that I did. All right, so I'm going to distribute the 2 through, so that would be 2x squared minus 6x, oops. Okay, up above on top of the two binomials here, I'm going to FOIL that out right up here. So 4x squared, that would be minus 6x plus 10x would be plus 4x, and then minus 15. Okay, and now keep in mind I'm subtracting that. So as I bring that down here, it's going to be minus 4x squared minus 4x and then plus 15. All over x squared minus 3x squared. Okay, so the next step requires me to know that when I have a whole fraction raised to a single power, that it's the same as writing it as the numerator to that power over the denominator to that power. And the reason why I'm doing this is because I noticed that this quantity of x squared minus 3x is actually repeated down here. And so I noticed that if I have the same quantity once in the numerator and the denominator of a product, I probably am going to be able to simplify it. So that's why I did that. All right, so I'm going to clean up my numerator here for this third term, and that will be negative 2x squared. I'm going to have minus 10x and then plus 15. And keep this as x squared minus 3x squared. Okay, so at this point, okay, I'm multiplying basically 3 terms here. I have 1/2, I have this business, and then I have this. And what I said I noticed is that I have this quantity to the 1/2 and this quantity to the second. So I should be able to cancel the smaller into the larger. Okay, so I'm going to go ahead and cancel this whole term into this, dropping my 2 by 1/2, which means my new exponent here would be to the 3/2, because 2 minus 1/2 is 3/2. Okay, so now what's remaining on the top would be the 1, which I don't need. So really it's just the negative 2x squared minus 10x plus 15. And on the bottom, I have 2. I'm going to rewrite this with a radical. So this would be the square root of 2x plus 5. And then this would be the square root of x squared minus 3x cubed. Okay, there you have it. That is our final answer using the first option. Now, like I said, we're going to go ahead and do this 2 ways. So here's the second way. Option 2 asks us to do the chain inside the quotient. What do I mean by that? Well, now I'm going to rewrite this up here. And as we said before, okay, we still have 2x plus 5, over x squared minus 3x, all to the 1/2. But I want to use that idea that when you have a fraction raised to an exponent, I want to pass that exponent out first. So 2x plus 5 to the 1/2 over x squared minus 3x to the 1/2. So now you can see we have the chain rule in the numerator and the denominator inside the quotient rule. So now the way this is set up is we're going to do the quotient rule, and then as we do the derivative of the top or the derivative of the bottom, that's when we use the chain rule. So it's just kind of flip-flopped. All right, so here we go with this. All right, so if we say f prime of x, so now like I said, I am thinking first quotient rule. So I have a big fraction, okay? And I'm using this last one. All right, so low would be x squared minus 3x to the 1/2. D high. So now I want the derivative of my numerator, which would be 1/2. Keep the inside, 2x plus 5. Drop my exponent, so to the negative 1/2, times the derivative of the inside, which would be 2. Minus, so that's my low, d high, minus high. Keep 2x plus 5 to the 1/2. D low, so same thing. Bring the 1/2 down, keep the inside, x squared minus 3x. Drop the exponent, so negative 1/2, times the derivative of the inside would be 2x minus 3, and I'm going to put that in parentheses. All over low, which is my x squared minus 3x to the 1/2, squared. Okay, and you'll notice here what happens when you raise something to the 1/2 and then to the squared. Well, you multiply these exponents, and 2 times 1/2 is just 1, so they're gone. All right, so f prime of x is equal to, all right, so let's clean this up. Here, if I look at my coefficients, I have two over here and 1/2 here. So half times 2, they go away as well. Okay, so all that's left here on the left-hand side of the minus sign on the top is x squared minus 3x to the 1/2 and 2x plus 5 to the negative 1/2. Minus, on the right-hand side, I do have the half, and then I have 2x minus 3. So 1/2, I have 2x minus 3, and then I have the 2x plus 5 to the 1/2, and I have x squared minus 3x to the negative 1/2. Okay, so looking at these terms, again, if we kind of break it down and look at what's on the left, oh, I forgot, should be all over x squared minus 3x. Okay, so now looking at these terms in the numerator, on the left-hand side of the minus and on the right-hand side, what terms are in common? And you can see you have these two quantities, x squared minus 3x to the 1/2 and to the negative 1/2, and you have 2x plus 5 to the negative 1/2 and 2x plus 5 to the 1/2. So we should be able to factor out one of each of those. Okay? So that would be x squared minus 3x. Again, compare your exponents, take the smaller one. The smaller one would obviously be the negative exponent. And then your 2x plus 5 to the negative 1/2. Okay, bracket. All right, so that's our GCF. Now, pull that out of either side of the minus sign in that numerator. So when I pull it out from here, okay, well, when I divide x squared minus 3x to the 1/2 by x squared minus 3x to the negative 1/2, you subtract these. 1/2 minus a negative 1/2 is 1. So we are left with, in fact, x squared minus 3x. The next terms, the 2x plus 5 to the negative 1/2, they match, so you're done. Minus 1/2, 2x minus 3. And then here this time, the x squared minus 3x to the negative 1/2 match, and we're going to be left with a 2x plus 5. Okay, all over your x squared minus 3x. Okay, so now let's clean up that inside the brackets there. Okay, and I can also notice here, let's clean this up as well so we can get rid of this. Here you have x squared minus 3x to the negative 1/2, and down here you have x squared minus 3x. If you want to think of it, it's to the 1. So this time the negative 1/2, we're going to bring the negative down to the denominator, okay? And when we combine it with the 1, we would be adding it. So it'd be x squared minus 3x to the 1 plus 1/2, which would be x squared minus 3x to the 3/2. So that's going to go down here, x squared minus 3x to the 3/2. We also have this next term, right, that we factored out, had a negative 1/2 exponent. So let's go ahead and bring that down. That would be the square root of 2x plus 5. Okay, so what's left on top is just what's inside the bracket then. Everything else I was able to pull down and join with the current denominator. So we have x squared minus 3x. All right, now I'm going to go ahead and FOIL these, and that would be the 4x squared plus 10x minus 6x would be plus 4x, and then minus 15. And remember, that's all. So it's minus 1/2 times this whole piece, 4x squared plus 4x minus 15. And it would be super convenient if that 15 was an even number, because then you could just distribute the half through, but it is not. And you don't want a fraction inside of your numerator. All right, so what we want to do in order to get rid of that 1/2 on the top, we can either get a common denominator, but that's kind of a mess. What you can just do is multiply both your top and bottom by 2, essentially multiplying by 2 over 2, which is multiplying by 1. And because you're doing it to the top and bottom, it is okay. So you end up with everything on the top getting multiplied by 2. So 2x squared minus 6x, okay, minus, now that 2 here times this 1/2 is obviously going to go away, which knocks that out completely, and now you basically just have what's inside the parentheses. So minus 4x squared minus 4x plus 15 over 2, and then your x squared minus 3x to the 3/2, square root of 2x plus 5. Okay, one last step, one last final cleanup. All right, so f prime of x is equal to, so in the numerator I can combine like terms, and I get that negative 2x squared and minus 10x plus 15. Okay, and in the denominator I have the 2. I'm going to write this as a radical, so that would be the square root of x squared minus 3x all cubed times the square root of 2x plus 5. And that, I believe, was the exact same answer as we ended up with last time. So 2 different methods. I'm not sure which way you like best. I know they were both long, and your eyes are probably a little bit crossed right now. So we're just going to wrap up with one final thing, and we will be all done. Okay, in conclusion, I want you to go ahead and test yourselves, okay? I want you to do the derivative of each of these symbolically, because if you can do them symbolically, that tells me you know the rules. So pause the video, get these all down, and see if you can complete and do the derivative for each of them. Okay, so if you compare your answers with mine, hopefully they match up. If not, please get the correct formulas down, and we can talk about any questions that you might have. Please make sure that you're studying up and that you know these formulas inside and out. It is crucial that you know all these rules so that you're able to properly apply them as we move further on. Thanks and have a great day.